During the 50s and 60s, PSL had been involved in a limited way in what is known as electronic warfare. As part of the Talos program, PSL performed work in an area known as warhead fusing for the Harry Diamond Laboratories. At the same time, PSL was also tasked by the Army Signal Corps to conduct several studies related to electronic countermeasures in general and against several specific missile systems. By building on its expertise in conducting field operations, developing and providing antennas, and the fusing work just mentioned, PSL was able to contract with the Army to provide electronic countermeasures testing support. Radar is an acronym that stands for Radio Detection and Ranging, and has been used since World War II to locate and track aircraft. Electronic countermeasures, or ECM for short, are used to defeat a radar's ability to locate and follow an aircraft. Here, much like shining a flashlight in a person's eyes, active ECM, otherwise known as jamming, uses a radio signal to deny the radar the ability to determine the correct distance to the aircraft. In this example, much like the House of Mirrors in a carnival, active ECM uses a radio signal to confuse the radar into thinking there are 3 aircraft, when in fact there is only 1. Passive ECM uses non-electronic measures. In this example, much like a person in a blinding dust storm, the radar is unable to see the aircraft because it is masked by chaff, which the aircraft released and which scatters the radar signal.
We're doing what is known as electronic warfare testing, and we provide test devices to the Army so that they might evaluate their own weapon systems. There are different types of electronic warfare that are used throughout the world, and this will help the various weapon system program managers to develop countermeasures to whatever electronic warfare is out there in the world. Typically, we'll receive a test plan from the Army, and that will specify the types of ECM devices, whether they're active or passive, and the quantity. And in this case, our contract deals specifically with air defense weapon systems. So they'll tell us what the air defense system is and what the target aircraft, in other words, the airplane that we're going to fly our ECM device on, that's going to fly against the weapon system, what that aircraft will be. If it's a commercial aircraft, we'll arrange for the proper clearances to put our devices on the commercial aircraft. If it's a tactical airplane belonging to the Air Force or the Air National Guard, we have other procedures we must do to coordinate installing our devices. We select the appropriate device. If it's in stock, we'll align it and calibrate it. If it's not, then if we have enough time, we'll have to actually develop it, design, do the engineering and fabrication and assembly, and all that's part of the contract. Once the ECM device is selected and ready to be operated, we have to transport that device from White Sands to the airplane, and that typically is Holloman Air Force Base, which is here locally, and a lot of times we'll be going up to Kirtland Air Force Base up in Albuquerque, New Mexico. Besides providing the ECM environment to do the field testing, the Army asks us to verify that everything is working properly, and we also man, operate, maintain receiver facilities here on the range that are capable of looking at the aircraft with the ECM device and determining if all the test parameters that are specified are appropriate and the mission accomplishment is likely. If it's not, then they can stop the test before a live missile is ever launched and save the taxpayer some money.
By this time in its history, PSL was a thoroughly experienced worldwide traveler with in-depth knowledge of the instrumentation needs as well as personnel requirements to support launch test operations, particularly in remote, unimproved locations. This knowledge and experience allowed PSL to gain 2 new business areas in the 1970s and 80s. One was the development of mobile, climate-controlled instrumentation vans, the other the development of high-performance, computer-based data acquisition and processing systems. Developing mobile instrumentation vans that are configured for easy setup, self-contained operations, and comfort for the operators is a challenge that PSL has been meeting for years. And for many of those years, PSL employee Mark Moore has been the supervisor of the mechanical fabrication shop.
Probably the biggest one that we've kind of developed is, since PSL does have a lot of field crews, and that was kind of where we first started building vans, was for ourselves, for field crews. we have I think our vans are probably more user-friendly than most because we've been in the field a lot ourselves. So that's kind of what we build into them, things to make them comfortable for people to use in the field. We were some of the first to put in things like microwaves and refrigerators and things like that to make it more user-friendly. And we, a long time ago, kind of originated the unistrut in the walls, and with putting carpet on the walls, I think we were some of the first people that put carpet on the walls in vans instead of paneling, and it just made it a lot more comfortable inside, deadened the sound a lot, made it cooler and warmer, and the unistruts was kind of a unique application in that you could mount and dismount equipment without tearing up the walls and things like that. Probably the mobile launch vehicle was the most challenging and the biggest project that we worked on. It was a unique vehicle. There wasn't one like it in the world, and we basically had to come up with a design, and went through a design phase and a design study phase to come up with a design that would work, and then to find the right commercial equipment and modify it to work in the mobile launch vehicle. So, and then the challenge of building the vehicle on top of that. We specialize more in one-of-a-kind and two-of-a-kind type of vehicles, and we build them special for the customer to fit his individual needs. And so, to me, the most rewarding thing probably would be to be able to work with the different customers from all the different services and government agencies and things, and to come up with a solution for their unique problems and to be able to build that into the vans.
As the systems undergoing testing become more sophisticated, the data requirements for the tests become more demanding. Developing data acquisition processing systems that can meet these demands is a PSL hallmark. Wade Craddock is one of the original systems developers at PSL.
In general, most of the systems work that I've been involved with at PSL, and a lot of it that I haven't been involved with at PSL, you could sort of characterize as it's data acquisition and control of, and then you fill the blank in. Sometimes it's MET sensor, sometimes it's high-altitude balloons, it could be sounding rockets. We've done facility control systems. Because of the laboratory's background in telemetry, a lot of them involved ground-based, either fixed or mobile telemetry stations. Understanding what the customer's problem is, what their requirements are. Sometimes they don't know. And sometimes what's put out on the street that you bid on is not really what they want. We've unfortunately been caught in a situation when we delivered a system that met every spec that we had designed and built it against. When it really got to the people that used it, they hadn't been involved in developing the specs, and they'd ask you, well, why did you do this? Why did you do that? And you'd go, that's what the spec said we had to do. And they said, we don't want that. So really the biggest problem is, if you like, getting with the customer, defining what the requirements really are, and working from there. Fixed-based data system, I guess, would be the one that I look back on most fondly for a variety of reasons. It was won competitively, not on low cost, but on superior technical proposal, which makes you feel good. It was done on a very challenging schedule. Very, very aggressive schedule, and the team that was pulled together to do it was probably the largest internal team that PSL has put together on a program. System was delivered, satisfied the customer's requirements and exceeded them. It was one of those that you were given a chance to do something innovative in, because they gave you a specification which just really told you what the problem was, what they needed done, and then let you figure out how to do it as best you could and bid it. And that's what we did. We won.